Okay, so we are in this part of chapter 7, we're talking about radicals, which are roots. So sometimes it's a square root or a cube root or a fourth root. But we're taking the root of something. And just some general rules on how we can change them, put them together, take them apart, things like that. So this first one just says if you have two things underneath a root, you can separate them with a multiplication sign in between. Okay? So, what's that? Um, yes, we'll talk about that in a little bit. So if we are looking at this example, so right now these are separate, but if we put them together, that would be the square root of what? Which is 4. Okay. On the next one, if we put these together, let's remind ourselves, we talked about this a couple chapters ago. If we have the fourth root, now if we have the prime factors of 27, what is that? 3, 3, 3. Okay, so we've got this 3 right here, and then we have these 3 3s. When we're taking the fourth root of something, what are we looking for underneath? A group of 4. Okay, so we have a group of 4 that we can take out of the root, so then we get 3 for our answer with nothing left over. Okay, so this is just showing that you can put roots together or take them apart if it helps you to simplify them. All right, so looking at these, this is review. This is what I was just talking about up here. We reviewed this in a previous chapter. So let's get the prime factors. So 16 is 2, 2, 2, 2. We're not going to write out all 24 A's or all 13 B's. But we are looking for groups of 4. So we have a group of 4, so that 2 is going to come out. How many groups of 4 are here? So we can take out 6 A's. How many groups of 4 are right here? But we still have a straggler left over. Does that make sense? We took all the A's out, right? Evenly. There were 6 groups here of 4. There were 3 groups of 4 right here. How many B's are left when we took those out? Just 1 B was left over. Questions on that? We're going to do another one, so hopefully it sinks in a little more. When there's not a number out here, what size groups are we looking for? 2. Okay, so we've got got 5 2's. We got 8 X's. So we're looking at groups of size 2. So we can take out a 2 and take out another 2. We multiply those together to get 4. And then how many groups of 2 are here? 4. So we take x to the 4th. And we still have square root what? 2. This 2 right here is left over. Okay, so the number on the outside of the root tells you what size groups you're looking for. You want to match. And then you can take those out of the root. Questions on that? That piece we've been through already, so that's a review. All right, so let's try a couple more just before we dive into the new stuff. Because if we understand this, it's going to make the rest of it a lot easier. All right, so we're looking for groups of size 2. So how many groups of 2 are there? X to the 4th. How many groups of size 3 are there? There's 2 of them. And there's 2 left over underneath there after we take out those groups of 3. Okay, same thing, but now we're looking for groups of size 4. There's 2 of them, nothing left over. We were able to take everything out of the root. And then groups of size 7. How many groups of size 7? 2. Groups of size 7? 0. Groups of size 7? Groups of size 7? 1. Okay, now let's talk about what is left underneath here. Are there any W's? No. There's all of these X's and Y's though, because we didn't take any of them out. So we got X6, Y3, and then how many Z's are left over? Just 1. Questions on the review stuff? All right. Let's dive into some new stuff. All right, so this is a similar rule. If you have things that are underneath a root that are being divided, you can separate them out into 2 separate roots, one in the numerator and one in the denominator. Okay, but we cannot have a root on the bottom. Remember, fractions are finicky. You can't have zeros. You can't have imaginary numbers. You also can't have square roots or cube roots or fourth roots or anything in the denominator. So we have to learn how to get rid of those. All right, so we're going to use this rule that is up here to split these apart right now, okay? So we've got the square root of x to the 6th over this, oh my goodness, ignore this scribble over here, the square root of y to the 7th. Now first we're going to simplify the top and the bottom just like we were doing on the last page, okay? So how many groups of 2 are there up on the top? There's 3 of them. So we can take out x to the 3rd. Is there anything left under the root? No. We were able to evenly take out groups of 2. How many groups of 2 are down here? Also 3. But we still have a root y on the bottom. Now back in geometry, you may have remember something like this when we were doing like 45, 45, 90 triangles. And we would end up doing something like 7, and we would divide by the square root of 2 when it was missing. How would we cancel out this root on the bottom? Not square it. What would we multiply the top and the bottom by? Come on, geometry kids. I had some of you. Remember this? We multiply top and bottom by root 2. What happens when we do that? What do we get on the top? 7 root 2. What about down here?
2.
We get 2. We get square root of 2 times square root of 2 is square root of 4, which is 2, and you no longer have a root on the bottom. So we're going to use that same idea, okay, up here. How can we get rid of this root y? Multiply by what? Root y. Okay, so we need a root y and a root y. So let's figure out what this would be. On the top, we can't combine those at all, so it's just x cubed root y. What's going to be on the bottom if we multiply all of that stuff together? It would be y to the 4th. This right here, we just get y, and then if we multiply that by y to the 3rd, we've got y to the 4th. We're going to go through more examples of this because they do get a little bit more challenging. But are there questions on that one? Anyone still need this slide? Okay, let's do this one. This one's a little tougher. We're going to start by separating them out, just like we did on the last one. Okay, so we've got the 4th root of 6 over the 4th root of 5x. Now, in order for the root to completely go away, we have to have the right number of things underneath this root so that we can circle them. What size groups are we looking for? We need 4 matching things, right? So we need how many more 5s? We need 3 more 5s, and we need 3 more x's. Okay, so what we want to do is we want to multiply the top and the bottom. It always is multiplied by the same thing, but we need to multiply by 5, 5, 5, x to the third, because when we put that together with what we started with over here, we'll have enough to totally take everything out of the root, and then there's no more radical on the bottom. So we need to multiply by the same thing up here. I'm just going to multiply those together, 125 x cubed. So this number on the outside of the radical is going to determine how many more things you need in order to have everything come out of the root. So we're just focusing on the denominator. So if we multiply across, if we put these items down here together, we'll have 4 5s and we'll have 4 x's. So what would that answer be if we take the fourth root of that? 5 and x. Okay, so on the bottom over here, we'll have 5x. Okay, on the top, we're going to put these together. There's not going to be any groups of 4 that we can take out because 125 is 5, 5, 5, and 6 is 2 and 3. So we can just take 6 times 125. Somebody tell me what that is?
750.
750. So we got the fourth root. And we've got x cubed. Let's check to see. And that's your answer. These are a little bit harder for kids to wrap their brains around at first. But the key is to just focus on the denominator and figure out what else do I need to put with this so that I have enough for everything to come out of the root. And then just put those things that you're missing into what you multiply your top and your bottom by. Questions on that? All right. Now we're looking here. So we're going to be putting together a bunch of things, a bunch of ideas, so that we can simplify this as much as possible. So first thing I would do is to multiply the things that are alike. So the things that are outside of the root, we multiply, and the things that are under the root, we multiply. So in the front here, we've got 6 times 4. So we already know it's going to be 24, and then square root of all the stuff that's under the root. But since it's under the root, let's keep it as prime factors. So 8 is 2, 2, 2. So I'm going to, instead of writing 8, I'm going to write 2, 2, 2. Then we've got this 2 over here, times 2. And then let's put the c's together. So that's c to the 4th and d to the 8th. Now we can simplify. Now, if we take numbers out, what do we do with the 24?
You multiply that plus 29
Yeah.
to the square root.
Whatever you take out, you multiply by that number in the front. So we're looking for groups of 2. So we've got a group of 2, a group of 2. So if we take these out, taking 24 times 2 times 2, and how many groups of 2 are here? How many groups of 2 are here? Is there anything under the root? No, we've taken it all completely out. Questions on that one? Okay, adding. Somebody asked about adding. Here's what we do with adding and subtracting radicals. In order to add and subtract radicals, it's kind of thinking of it like terms. What's underneath the root needs to match if you want to put them together. Okay, so it's kind of like having an x and an x. You can't add an x and a y together, but you could add x and x. So what we're going to do is we're going to going to just simplify each of these radicals right here, and then we'll see if the radicals match, and if they do, we can put them together. Okay, so we're looking at 4, and then 2, 2, 2, 3. What's the prime factors of 50?
5, 5, 2.
Looking for groups of size 2. So we've got this here that we'll take out, this that we'll take out. So our first one is what? 8 root 2, 15 root 2. Now I said to treat it like a variable, combining like terms, so what do we really have here, do you think? 23 root 2. We would take 8 plus 15 for our answer. But you can only combine those if the roots match. Otherwise it would just stay separate. Like if this was 15 root 7, then that would just stay your answer right here, this step before. Okay, so you can only combine them if the roots match. Questions before our last page? All right. Let's look at this one. Thoughts on what we're going to do?
Multiply.
We're going to multiply. How should we organize it? In a window? Yeah, we need to window this. So let's do that. Window or foil. Foil would work just as well too. So I'll take 6 root 3 minus 5, 2 root 5, 4 root 2. Now remember, when you're multiplying radicals, the things that are in the same position get multiplied. So the ones outside of the root get multiplied, and the ones under the root get multiplied. So if we're looking at this first square right here, what would that mean this is? Yeah, we'll take 6 times 2, and then we're going to take 3 times 5 and get 15. Okay, what about right here? Minus 10 square root 5. There's no other root to combine it with, so it just stays there. What about down here, lower left? 24 root 6. And the last one, minus 20 root 2. Now the next step is to make sure that all these roots are as small as they can go. So let's think about this. Can we break 15 down? 15 is what? What times what? 3 times 5, there's no pairs here. 5, that's as small as it goes. 6, 2 times 3, can't break that one down. And 2 is as small as it goes. So none of them can be simplified. Are there any that we could combine as like terms?
No.
No, so it doesn't matter what order you write this in. There's no right or wrong. I'm just going to start at the top. 12 root 15 minus 10 root 5 plus 24 root 6 minus 20 root 2. And that's your answer. All right, last guy. Right here. So this one is another one where there's a root in the denominator, but we're not going to be able to simply multiply by the square root of 5 because there's that minus sign on the bottom. Okay, so the way that we're going to do this is when you have either a plus or a minus down there and there's a root, we have to multiply by what's called the conjugate, okay, which is the same expression, but you change the sign in the middle. So we're going to multiply by root 5 plus 1 on the top and the bottom. Now on the top we get to just distribute, but on the bottom we have to window that. So on the top, let's get that going at least. We've got 2 root 5 plus 2 when you distribute the 2. On the bottom, we're going to do another window. We've got root 5 minus 1, root 5 plus 1. Let's take a look at what happens. Root 5 times root 5. 5 minus root 5 plus root 5 minus 1.
5 minus 1.
These cancel out, and we've got 5 minus 1, which is 4. Now this can be simplified a tiny bit more. Not always going to happen. But when you have every single term divisible by the same number, we can do that. But it has to be every single one. What can we divide all 3 terms by? 2. So if we divide this one by 2, this one by 2, and this one by 2, what would we get? Root 5 plus 1 over 2. Now, you are not always going to get what looks like just the flip-flopped version of the original. That's a coincidence. So don't think that you can just flip the numbers and change the sign. Okay? Questions on that?